Hello everyone, welcome back to my YouTube channel Study with These. Today we shall deal with packet switching. In packet switching, there are two types, datagram packet switching and virtual circuit packet switching. So, what is packet switching? Packet switching is a switching technique in which the message is divided into packets and they're sent individually so that the data will be transferred efficiently and in a very faster way. The two types of packet switch network are datagram network and virtual circuit network. So, what is datagram network? It is a packet switching technology in which the packet are called as datagram and each packet is considered as an independent entity. So each packet will contain an information about the destination and switches will use this information to forward the packet to the correct destination. This packets, once it has been received at the receiving end, might not be in the order that was sent by the sender. Hence, at the receiving end, they have to reassemble in the correct order that was sent by the sender. In datagram packet switching technique, the path is not fixed. So, intermediate node will take the routing decisions looking at the routing table which they have to forward the packets. So, datagram packet switching is also known as connectionless switching. These datagrams can arrive out of order with the different delays between the packets. So, packet might also get lost or dropped because of lack of resources. In most common protocol, it is the responsibility of the upper layer protocol to reorder these datagrams or ask for the lost datagrams before it passing them to the upper layer or the higher layer or the application. Here, there is no connection establishment or connection termination, or that is setup or teardown phases here. It is only the data transfer. So, what is routing table that is there in the switch, which is present in the datagram network? So, each packet has a routing table depending on the destination address. These routing tables are dynamically updated periodically, but certain duration of time they keep dynamically updated. Next, the destination address and the corresponding forwarding output ports are recorded in these tables. So once the destination address in the header of the packet of datagram network remains the same during the entire journey of the packet. When the switch receives the packet, the destination address is examined and the routing table is looked into to find the corresponding port through which the data can be forwarded. Then, looking into efficiency, it is efficient compared to circuit switch network. Why? Because the resources are allocated only when there are packets to be transferred. For instance, if the source sends a packet and there is a delay of few minutes before another packet can be sent, that gap or can be utilized, that resource can be utilized for reallocating during this gap so that other source can send the packets to some other destination. Resource is not wasted, it is used efficiently. That gap has been filled instead of blocking it for same sender and the receiver. Switching in the internet is done by using datagram approach at the network layer. This is very important. If you can see here in the diagram, 1232, if the destination address is this, then the output port is already decided. It should be 1. So this is how it has been populated, and depending on the destination address, the output port has been again decided. You will understand better here. Delay in the datagram network, there is no setup or teardown phases, but once, if you can see, A is sending, in between there are two switches, and B receives. Here, whatever it is being sent, since the resource was not available at that particular time, there is a waiting period here that has been introduced. Because of this, there might be a greater delay in the datagram network compared to virtual circuit network. So this is what it has been recorded here. If you can notice here, waiting time and waiting time here, and total delay is so much. So there is a delay in datagram network compared to virtual circuit network. Next, coming to virtual circuit switching network, here it is a cross between the circuit switch network and the datagram. Wherein circuit switch network is a hardwired path you will have, and datagram you don't have any path at all, so it is a cross between these two. Basically, it means there is a logical path existing here. So packet from a single message travel along the same path. So three phases here are data transfer are setup, data transfer, and teardown. That is connection establishment, data transfer, and connection termination. So resource can be allocated during the setup phase, and data are packetized, and each packet carries an address in the header. And this is basically implemented in the data link layer. The before one was at the network layer, and now it is at the data link layer. If you can see here, end-to-end systems are there, and in between there are so many switches, and any path that is been established, all the messages of that message will be following the same logical path. So here, two types of addressing we have to look into. One is global addressing and then is local addressing. Initially, before the connection establishment, the source and destination needs to be a unique address that only switch will use to create the virtual circuit identified during the setup phase. Once the setup phase is done, then VCI, that is virtual circuit identifier, that is a local addressing that will be used to transfer the data between any two systems or switches. So this is a very small address which is used by a frame between any two switches. If you can see here, here it has VCI 7714. Likewise, depending on the VCI and the port, it will decide which output port to go and what will be the next VCI of it. Suppose data with 14 VCI is coming through port 1, then it has to change the VCI to 22 and it has to send via port 3. This is what this port table will talk about. Next, how to set up the connection, that is connection establishment, setup phase. So, if you can see here, A is sending a packet, okay, with the source and destination address. Here, a 14 VCI is also passed. It is coming through port 1. So, here looking at the destination address, the switch will decide which output port to take. So, 3 is the output port, it has decided at this example. So, all these 3 are marked, but this we do not know. This we get to know only during the setup acknowledgement phase. So, it is passing it here. Same thing here, while passing, it will change the VCI to 66. So, it is coming from port 1. It is not that because it was port 1 here, it is port 1. No, no. It is through port 1 of this second switch it is coming. So that's the reason here it is port 1. And VCI was changed to 66. It has been recorded here. And now output port it has decided is 2. That's the reason it is 2 here. Again, this 2 and this 2 will not match. It can be 1 also. If it was 1, it would have been 1 here. But since it is 2, the input port is 2, and here while coming it changed the VCI to 22, hence it has been changed, and output port is 3. It went to B, it has reached the B. Now we have to look into the acknowledgement phase. Now we will write VCI 77 and it will send here, and once if it is the port 3 and VCI 77, then it knows it has to change the VCI to 22 and it has to forward it to port 2. So that is what it is done. And here again this will be recorded. It will change the VCI and it is done. Once all these four fields are been recorded, you get to know if any incoming packet from port 1 and VCI 14, then it simply means it has to reach destination B. This switch will get to know and it will forward depending on the routing table. It will pass it to port 3. So here only local addressing is used after the setup is been done. File data transfer, you only look into this VCI and nowhere here global addressing is considered after the setup phase. So that is how the data transfer shall happen. Once you see the port number and the VCI, you know what is output port and what is the VCI you have to change. That is the way it has been done, and all the frames shall follow the same path. And once all the data has been transferred, the data teardown process has to happen. So B will initiate, the destination will initiate a teardown frame. So all these values will be deleted from the end. This entry will be deleted and it will be freed. So it simply says that connection is no more existing. So that is connection teardown phase. But what is the delay in the virtual circuit? If you can see, like previous one, we don't have any delays in the data transfer phase. But whereas there is a time that has been killed here during the setup phase and the termination phase. That is one, you send the frame for a setup, then next is the acknowledgement, and here tear down, frame is being sent. So this is the delay. Otherwise, there is no delay between in the data transfer. Hope you have understood. Thanks for watching. For more information on computer networks, keep watching my channel Study with Ace. Thank you.